Greetings, everybody. Welcome to today's webinar, part of the Transforming Data into Digital Assets webinar series presented by PIMSoft. I am Ryan Bolin, your moderator, and we thank you for joining us and hope you find this webinar informative and valuable. Today, we want to discuss how Sigmafine energy balancing powered by its thermodynamic extension supports accurate performance monitoring of equipment and energy networks, i.e. steam, fuel, gas, etc. In this webinar, you will learn about data reconciliation applied to KPI evaluation, Sigmafine components to implement model-based performance monitoring, use cases demonstrating Sigmafine capabilities. Now it is my great pleasure to introduce our presenter for today, Marco Lanteri, PIMSoft's Industry Principal for Refining and Chemicals. Marco?
Thank you, everybody. Thanks for joining us today. I would like to just introduce us as PIMSoft and our product Sigmafine. PIMSoft is in the business of ensuring accuracy, reliability, and usability of your process and manufacturing data. And it's in this business since 1995, so it's a long path, many years in which technology, processes, workflow have changed dramatically. And our Sigmafine platform has changed a lot too, has evolved, and it's still evolving. It's now leading towards web environments, web usage. It's also changed a lot in the way it's used. We are currently talking today about performance monitoring. Last time we talked about tracking of properties. So more and more different scenarios where Sigmafine can be used, and so it's enlarging its use base. Let's start now with the main topic. The title was Model-Based Performance Monitoring. So I wish to start with performance and monitoring, and then we will see together what we mean also by model-based. By performance, we mean, and typically industry means, checking productions, yields of an equipment, efficiency, or verifying the difference between actual performance against a baseline that can be a design condition of your plant or some industry references that you want to compare. By monitoring, we typically mean you have a process historian or other database where you're storing your process data and you are checking them typically by trending, by analyzing, or nowadays with dashboards, web views. The goal, of course, is to improve operations by having a close monitoring of your processes, improve the asset utilization, the maintenance. For example, you want to better evaluate the heat losses and compare with possible fouling in your heat exchangers, reduce consumptions and emissions. Another important role is supporting the energy manager and energy engineers, especially, I would say, in Europe, it's the ISO 50001 framework is very well deployed, and there is a large use also in terms of trading green and white certificates, where green are related to CO2 emissions and white certificates to energy efficiency credits. But let's say we always talk about KPIs. Yourself or your customers are asking for KPIs. They want to see them on their screens, on their mobile phones. But not always we are questioning about the accuracy of such KPI. And accuracy in reality matters a lot. And here I brought to you a very simple example. So let's say that you have a process, could be, for example, a distillation column or a reactor or whatever, and you want to assess the specific energy consumption per unit of valuable product that you are producing. So in this case, there is a product rate that you are measuring. You are using steam to provide energy to your equipment. So this is your energy consumption. And you want to calculate your KPI. So you put together the numbers, you check the conditions. For example, in this case, we calculated the latent heat of the steam at 1.8 bars, and you have your value. But let's question also the accuracy associated to such KPI. So we indicated per each of the measured or inferred variable, its accuracy. So product rate, for example, is associated with a 1.5% accuracy. Steam rate is not measured so well as the product rate, so it has a larger tolerance, so 2.5%, while we are quite confident in the measure of pressure and on the steam. Since we are using steam table, which are very well tuned, the accuracy is quite high, so 0.5%. If we combine all this together, we can derive also the associated accuracy of the KPI, which ends up to be plus or minus 3%, which is not a negligible number at all if you think of the value of a big energy consumer that you may have in your plant. So why now? What Sigmafine can say in this picture, and what means using a model-based approach? Sigmafine is a validation and reconciliation platform. You are classically seeing it as a way to do production accounting or yield accounting, but in reality, you can use it as an online validator that can apply and constrain data with first principles, so conservation of mass and conservation of energy, act them around your equipment, especially your most sensitive equipment, and get KPIs which are more reliable and more accurate as you're reducing the uncertainty associated to all the parameters you're using to calculate such KPI. So the goal is to provide a platform which is more robust on which to take your decision. For whom of you that are not very deep in Sigmafine technology, basically Sigmafine brings data from your plant, typically through a historian or even directly from the DCS or from through interfaces. And which parameters are we interested in? Well, level gauges, flow rates, temperatures, pressures, analyzers. For example, if we take a level and then we apply a strapping table or some geometry calculation, we can calculate the total inventory associated with it. For example, around flow rate, we can use temperature and pressure to apply compensation. Therefore, evaluate and get the associated measured mass. Similarly, if we have temperature, pressure, and composition, through the use of thermodynamics extension, can be equation of states or can be even the steam tables themselves, you can end up in calculating values like enthalpy of mixture. So if we now have stocks, so your inventories, your compensated mass, and your enthalpy, we have all the required inputs for a Sigmafine model, which is a topological representation of your equipment, of your plant, of your facility. We can run a mass and energy balance, and so reconcile this input data in order to get a consistent data set and accurate KPIs. So if we apply data reconciliation to the example we provided before and we compare raw and reconciled process data and KPIs, we will end up with slightly or larger numbers. In this case, for example, we can recalculate the KPI and the specific consumptions and be a bit lower compared to the ones based on raw data. It's not only the new value that it's a value calculated satisfying the mass and energy balance. It's also the fact that the new value has a much smaller uncertainty. So from 3%, we end up to below 2%. So we achieved a value which is much more reliable than before. So the main goal of Sigmafine, as I said, is to give you a platform of decision which is much more robust than the one you may have just using raw data. We will see now some real use cases where these concepts have been applied and deployed. So the first use case is indeed a distillation column, is a purification of ethyl benzene and styrene. This column is quite large. It's one of the main consumers of this chemical plant. It's a styrenic plant. We made a first, before applying Sigmafine, we made an analysis on the raw data, and we have calculated the imbalance which was affecting this equipment. And we have seen there was quite a large imbalance, both on the mass and on the energy side. And moreover, not only there was quite a relevant imbalance in the data, but also quite a large data variance, especially affected the energy side. So the goal here was to get rid of such imbalance and have accurate KPIs regarding the steam consumption at the reboiler of this column, and compare the steam consumption against the purity of the distillate at the top and the bottom, which are the main value that are checked by operators to stay in specific. So what we did, we took as data sources the historicized data. This customer had the data historized in a PI system. And we were picking up the flow rates, the temperature, pressure drop across the column, and the online analyzers data. We created a model targeting this equipment. You can see in this case is quite a simple model compared to a Sigmafine model of a refinery, of an integrated refinery and petrochemical that we are typically used to. Of course, you can extend this to many more equipment and overcomplicate as you want. But let's say in this case, we just focus on one single equipment. The model was then configured acquiring the raw data and applying the thermodynamic extension to characterize and evaluate the enthalpy of all the streams. So for the process side, Peng-Robinson has been used as an equation of state, whilst the steam tables on the utility side for steam and condensate. Then a mass and energy balance analysis has been run, and it was automatically scheduled to run every 10 minutes. So in this way, we achieved a near real-time monitoring of the equipment, and even all the results were automatically published on a SQL database, which was then feeding a typical layer that customer had for business intelligence as a business intelligence platform. Let's see a comparison of the results that we got. So we recalculated all their main KPIs that were targeting this column. So we have seen an increase of the reflux ratio, of the number of theoretical stages, and moreover, a higher specific energy consumption at the reboiler. So effectively, they were spending more than they were thinking of. They were using more energy than what they were expecting to use. And this was affecting negatively, of course, the efficiency of the production itself. So this difference could be even accounted on a numeric, on a pricing number. So it was around 2,000 euros per day of additional energy that was in reality consumed by the equipment. So what the customer did in the end was to bring all this data inside the control room, so that operators could have a tight check of how the performance of the column was behaving, and react and work closer to the product purity limits. So trying to reduce a bit the steam consumption of the equipment. The other impact was in the calculation of the energy manager, which based on the new consumptions reassessed equipment maintenance plans and possible improvement on the equipment. In the end, the energy manager did an assessment of the equipment performance against the best available technology reference. And from that difference, they could claim a number of energy efficiency credits at the time when EECs were worth about 100 euros per day. They could claim around 6,500 euros per day of efficiency credit. So this is the first use case I wanted to bring to your attention. In the next cases, we will see applications to other areas in other plants. We have used such approach to cracking. More specifically, we adopted a massive mass and energy balance to a full ethylene production plant. In reality, in the real case, these are free trains, basically, where we targeted the close energy monitoring of all the main energy consumers, so not only the cracking furnaces, but also the main compressors and coupled turbines and the fractionation section. Today, otherwise it would be too long, we will just focus on the cracking. So this is how appears a Sigmafine model targeting a gas cracker. In this case, there are two parallel ethane feeds, which are preheated with flue gases and then are heated inside the firebox. In the firebox, Sigmafine is calculating the heat generated by the combustion of fuel gas and the heat required by the cracking reaction. So the heat of reaction is estimated based on conversion data between input and output, as there were analyzers both on the input and on the output of the fire heater. It's taking into account the oxygen, the excess of oxygen in the flue gases to reassess the amount of total air flow to burners, as this was not directly measured, was only partially measured. And as KPIs, in the end, we could provide an estimation of the amount of heat recovery from the flue gases per each stage, the amount of heat losses to stack, the radiant losses to ambient, how effective were the quenching heat exchangers after the cracking unit, and the overall duty and efficiency of their equipment. In this way, the new efficiency was able, of course, was based on the closed mass and energy balance and closely monitoring at how the curve of efficiency around the days was changing, could also help in assessing the current level of fouling in the firebox itself. The last case I would like to present today is the application to large steam networks. This is another typical case you have in your plants. Steam network is quite hard because of many different things. First of all, the size. Steam and condensate network is typically quite large. It could be really large in some cases. You don't have so many measurements like on the process side, as you are just interested in just monitoring, for example, the levels of the water in the steam drums, or some temperature or pressure here and there, but you're not closely monitoring the flow rates of each stream of steam. Typically, what we see is the situation of a balance made with large Excel sheets, trying to capture the main consumers and trying to do balance, a rough balance. A balance that is typically on monthly basis. It's hardly to maintain a daily basis a balance of large steam network with Excel. In the end, we have seen it's you are having a missed opportunity. This network is really one of the main drivers of the energy across your plant. So if you don't proper monitor, you miss opportunity of deciding, for example, how to better drive steam across the different levels, or if driving more through the turbine or through letdown stations. So on this side, Sigmafine helps because you can create, again, a full detailed model of your steam network, representing the steam headers, turbines, letdown stations, condenser. So you can represent all of the objects that are making up your steam distribution. You can then map flow rates and perform enthalpy calculations, typically via steam table, and have, by coupling mass and energy balance, have a very high level of redundancy, because once you're missing some flow rates, you can recover them by using the enthalpy information and vice versa. So in such way, you can end up in having a balance, a close balance of the network that can then be run when you want. So typically even daily, or even at a higher rate if you have all the data available on that frequency. The final goal, of course, is having operations that can really look into, and in near real time, to the situation of their steam balance and decide how to better drive the steam across the network. So it's again a question of taking decision at the right time. So here is like last time we talked about tracking, and again was having the information at the right time. The same here. You don't have to wait somebody, the energy manager, or who is in charge of compiling the full steam balance and just account for the steam consumed at the end of the month. You can act today. Let's wrap up. Who should be requesting Sigmafine applications in performance monitoring? And now I'm telling to especially to the ones that have already installed Sigmafine. They are maybe using Sigmafine in production accounting, and they can think of extending the use on the steam, on the equipment, let's say, on the energy business. So first of all, the production. So have trustable KPIs for the large energy consumers, and for big energy networks. So I'm thinking about fuel gas, fuel oil, steam, as we talked before. The energy manager, which is another key figure that can use Sigmafine data, as they can get rid of the energy imbalance affecting the unit and reevaluate and assess the real performance of the equipment and take initiative to improve the efficiency. Optimization, the reconciled layer can be use them to feed at a higher level real-time optimizers. So if the grant for real-time optimizers should be a data set that is validated and reconciled. And finally, more popular today than ever, the data scientists, if they want to run predictive or machine learning tools, they should start from validated data, and reconciled data are among the best data they can use to start doing their predictions. So let's say with this, I have almost finished today. Brian, I leave back to you.
Thank you for this great presentation. First question, how do you calculate uncertainty of reconciled data?
Okay, the uncertainty associated with reconciled data is calculated automatically by Sigmafine. Let's say this is once you solve the data reconciliation problem, you have an associated covariance, and let's say, so per each reconciled value, you also have an associated variance of this value itself. Yeah. So Sigmafine can provide you this information.
Next question. If steam flow to a heat exchanger is not measured, can they be calculated by doing a heat duty calculation using the product flows / temperatures?
Yes. Let's say you can represent in Sigmafine, you have two possibilities. Either you use a standard heat exchanger template, which is mapping the shell tube side standard heat exchanger, so you represent both the two passes, the cold and the hot side. Or you can even more generally specify even one side and the associated heat flow, or on the opposite, even model more complex heat exchangers arrangement by representing the different passes and heat flow, heat exchanges. So if you specify, in your example, the input and output information on the product side, of course, you will end up with an associated duty that is passed to the utility. In this case, you're just solving, you're not reconciling, because you're just providing one side of the information. The true value, it comes when you have both the two information on the product and on the utility side. So the two on the two sides, you will come up with probably a slightly different duty, and the model will reconcile it. So here is the real value of the reconciliation.
Is the produced fuel gas in the cracker part of the mass balancing, also reconciled using the energy balancing, since it is sent to the cracking furnaces?
Yes, in let's say, of course, in the picture I've shown only the cracker side, but in reality, the mass and energy balance has been used for the overall plant, so including the recycles back to the fuel gas side that is then burned. So yes, it's integrated.
We had one more question that's not showing up in my queue list, but it says, how do you check balance is correctly done and how to find which flow meter is an issue?
The fact that you are creating a model and you are constraining all the data to satisfy the same first principle equations contributes to create redundancy in the information. So the more input information you have, typically the more robust the level of redundancy will be. Therefore, if then after doing the balance, you look at the most corrected values compared to the tolerance that you assigned at the beginning, Sigmafine will tell you, and it's providing specific indicators for that, which are the ones mostly corrected and that you should diagnose more in.
Can you explain shortly the difference between validation and reconciliation?
Okay, validation typically is applied on the input data. So, for example, we verify, for example, applying compensation, checking that the value is within limits, doing some checks for that the model has no gross error associated, like, for example, if you have movements that needs to be captured and that there are no large imbalances around the tanks where the movement should occur. So all these kind of pre-checks, these are the part of validation. Reconciliation is instead the technique in which you apply the balance, but not only calculate a balance, but you apply a minimization of the error associated to all the measurements constrained by the balance itself. So you can see validation as a preliminary step, and reconciliation is the real act of balancing and minimizing the error.
Last question, unless y'all have some more, please feel free to keep asking if you do. Is if there are more manual inputs, does it impact the balance?
Let's say more than the balance, it impacts the workflow. So what we said that you can run, for example, a performance monitoring every 10 minutes would not be possible if you have manual inputs. So if you are targeting a performance monitoring, you should ensure that all the data comes automatically and in a straightforward way to feed the model, because nobody will be in front of Sigmafine screen looking at the model. So it's a really different way of use respect to production accounting. So in that sense, you should not even have manual inputs. If you run instead a daily steam balance, maybe yes, you are allowed to do some manual inputs because you have the time to do so. So maybe coming also back to the questions, the question before, the validation is even more important in this case, because you have to ensure that you don't receive any bad data. And if you receive bad data, for example, some data are not coming from historian, you should be able to supply something in place of it. So there are all a set of techniques to make sure that the equipment balance is always solvable without a manual intervention.
We had a couple more questions come in. How will KPIs be available to clients through PyClient applications?
Well, that really depends on what the customer has in place. So you have to see here Sigmafine as an engine providing all the reconciled data and the KPIs if you want to calculate directly in Sigmafine, or you can decide to calculate the KPI outside Sigmafine directly in PI or the other historian, or even directly in a business intelligence dashboard or in a reporting tool. So this, frankly speaking, you are quite agnostic on how, let's say, the KPI shall be exposed, and this depends more on what the customer has on its side.
Can Sigmafine the built-in uncertainties and error propagation due to instrumental errors, such as KPI uncertainty, cannot be reduced below some number, say 2%, etc.?
Well, let's say in reality, okay, the uncertainty associated to the KPI depends on the uncertainty calculated on the reconciled data. So once you perform the reconciliation, the tolerance associated to the reconciliation depends on how good the and how good the initial data were. So the KPI uncertainty is derived from the uncertainty of the source value, and there are let's say basic rules to calculate it. So it's not something that you can say, okay, you can't go below %. So it depends on on the outcome of the reconciliation.
What are all the parameters to look out for to build more working, robust models?
Well, as I said before, you need to ensure that the model is always solvable, and if there are, so you have to look at the inputs, and per each input that ends up, in the end, the input for the reconciliation on a mass and energy basis are the mass and the enthalpy, essentially. So you need to make sure that these two numbers are always available to the reconciliation step. So, for example, you have to check among the temperatures and say, so you read probably the temperature inside the attributes, and if you have to check that this temperature is between some limits, or if there is a bad val, then maybe use a standard design data in place of it. So you need to do maybe a bit more of configuration to prevent, let's say, the bad actors to influence the results. Or sometimes you guess division by 0 because some data are not coming and you receive a 0. So this kind of, you have to try to capture the most that you can, and then once you run for maybe 1 month, you discover, looking at the data, some odd values here and there, and you maybe need to adjust a bit more the model to capture them.
How do you link Sigmafine output data to a web Power BI dashboard?
Okay, so in the case when we did it, there are different ways, but let's say when we did it, we published all the Sigmafine data with SQL access. So the data are openly available in a SQL database. And then there was automatically a publisher that was connecting this SQL database with the data model of Power BI. So Power BI then refresh the data, picking up from the published data from SQL. So, and behind all of this, there is always the scheduler that is the job. So the scheduler is entitled to collect all the information, run the reconciliation, publish the data to SQL, and on the other side, the BI publisher that was automatically picking up the data from the SQL database. Another way around could be to publish the reconciled data to the PI system, if you have a PI system, and associated analytics. And then I guess OSI has a BI integrator that can connect PI to the Power BI. So there might be different ways to do it.
Is Sigmafine used to track drifts in instruments and drive calibration?
Yes. Okay, this is more related, I would say, to the classic mass balance rather than energy balance. Typically you can check this by monitoring the Sigmafine indicators associated to the different measurements. And if you see that such indicators are deriving during time, so of course you don't capture this in 1 day or 2 days, but if you have a look at 1 month of data that you have published, and you see a trend, a deriving trend so that the correction is slightly higher and higher, and then you probably got a drift. In this sense, let's say these new predictive analytics tools are quite nice because they can also couple very well together with Sigmafine once you publish this information.
Marco, on behalf of all the participants and PIMSoft, we thank you for taking the time to participate in our webinar and share your knowledge. We'd like to thank everybody for coming out. Anyone interested to continue the discussion in performance monitoring can contact Marco directly at the email provided. We'll hang on here just a few minutes to see if there's any other questions that come in. Once again, we thank everybody for coming out. And if you have any questions for Marco, please feel free to contact him directly.
Thanks everybody for attending. And yes, I'm available in case something is not clear to come back.
Thank you.
Thank you.